Hello everyone, welcome to my YouTube channel Easy Way to Learn. I'm Shailja Tripathi and today we'll be doing numericals based on current. See how current is related to charges and number of electrons. So let's get started. See, our first question is a current of 1.5 ampere flows through a conductor for 2 seconds. What amount of charge passes through the conductor? Okay, to solve this question, we'll use the relationship current is equal to rate of flow of charge, that is Q by T. So rate means the physical quantity charge is divided by time. So in the question we are given the value of I, that is 1.5 amperes, and value of T is given, that is time, 2 seconds. So we have to find Q. So Q will be equal to I into T. I into T. That is 1.5 into 2. That is 3 coulomb. Now let's come to another question. See, in this question, a charge of 0.5 coulomb passes through a cross section of a conductor in 5 seconds. Find the current. Okay. So, charge Q is given 0.5 coulombs, time T 5 seconds, and we have to find I. That is nothing but Q by T. So 0.5 upon 5 you get 0.1 ampere. Ampere is the unit of current. Or you can also write 0.1 coulomb per second. So another unit is coulomb per second. Coulomb upon time, that is seconds. Let's come to another question. See, when a starter motor of a car is switched on for 0.8 second, a charge of 24 coulomb passes through the coil of the motor. Calculate the current in the coil. So, we are given time 0.8 seconds, charge Q is given 24 coulomb, and we have to calculate I. So write down the formula. I is equal to rate of flow of charge, that is Q by T, that is 24 upon 0.8. So you can write 24 into 10 upon 8, and on solving you will get 30 amperes. So this is the answer. So these are few of the very easy questions, but you need to remember the formula. Let's see this question. See, a current of 1 ampere is drawn by a filament of an electric bulb. Number of electrons passing through cross section of the filament in 16 seconds would be roughly. So here we have to find out number of electrons that are passing through the filament. So in this case we are given current I is 1 ampere and time is given. Time is 16 seconds. We have to find charge. First we'll find charge and use the relationship Q is equal to N into E. Value of E is already known. E is charge on 1 electron, that is 1.6 into 10 raised to the power minus 19 coulomb. So first we'll find out the value of Q, then we'll find out the value of N, because it is asked find the number of electrons. So small n is representing number of electrons. So we have to find Q, then followed by small n, that is number of electrons. Okay, so current is nothing but rate of flow of charge. So here we get I into T is equal to Q. So I is 1, time is 16, so we get 16 coulomb. So charge is 16 coulombs. Now use this relationship. Q is equal to, that is total charge is equal to number of electrons multiplied by charge on each electron. So let's rearrange. Number of electrons is equal to total charge upon charge on one electron. So we get total charge is 16 coulombs divided by 1.6 into 10 raised to the power minus 19. So on solving you will get 10 raised to the power 20. So these number of electrons are flowing through the filament. Let's see this question. See, the charge possessed by an electron is 1.6 into 10 raised to the power minus 19 coulomb. Find the number of charge that will flow per second as to constitute a current of 1 ampere. Okay, so in this case, see, we are given time, that is time is 1 second, and value of current is given, that is 1 ampere. We have to find number of electrons that are flowing. Value of small e, that is charge on one electron, is given. This is a constant. If it is not given in the question, you must remember this constant value, you have to learn it. Okay, so first we'll use the relation I is equal to Q by T, that is I into T will give you Q, and Q is equal to, that is total charge is equal to number of electrons into, this value will be equal to number of electrons into charge on each electron. Now we can use this relation and this relation and find number of electrons. See, I into T, that is I is 1, T is also 1. Number of electrons N, and this E will go in the denominator. N into E will come here. 1.6 into 10 raised to the power minus 19. So on solving this, you get 6.25 into 10 raised to the power 18. This is the value of number of electrons. But electrons are never in fraction or in decimal. So this is equivalent to 6 into 10 raised to the power 18 electrons. That is, these many electrons will constitute 1 ampere current flowing for 1 second. Let's come to our last question. See, a conductor carries a current of 0.2 ampere. That is, value of I is given 0.2 ampere. Find the amount of charge that will pass through the cross section in a conductor in time t is equal to 30 seconds. So this is the first part that we have to solve. Equal to Q by T. So I into T will give you value of Q. So I is 0.2 and time is 30 seconds. So Q comes out to be 6 coulomb. Now let's see the second part. See, how many electrons will flow in this time? That is, time will be same, that is t is equal to 30 seconds, and we have to find number of electrons if charge on one electron is given, that is value of E is given. See, we have to find number of electrons. So Q is equal to, that is total charge is equal to number of electrons multiplied by charge on one electron. So here we have to find value of N, that is Q by E will give you small n. So Q is 6 coulomb divided by 1.6 into 10 raised to the power 19. Sorry, minus 19. This we get 3.75 into 10 raised to the power 19 electrons. So these many electrons constitute 6 coulomb charge. Understood these questions quite well. Please like, share and subscribe and keep practicing the numericals. Thank you so much.